This tire costs $63,000, just the one. And the machine it sits on burns through 50 gallons of diesel every single hour. That works out to about $175 in fuel before you even move a rock. But here is the part that nobody expects. When the engineers in Longview, Texas, sat down to design the largest wheel loader ever built, the biggest problem was not the 2,300 horsepower engine. It was not the hydraulic pumps, or the lift arms, or the steel frame. It was the rubber. No tire manufacturer on Earth made a tire large enough to carry this thing. The engineering team had to partner with Firestone to invent an entirely new tire from scratch. That development process alone took 18 months. Today, we are counting down the 10 biggest wheel loaders operating in mines across the world right now in 2026. Machines so massive, they use the same propulsion technology as freight trains. Loaders controlled by remote from nearly a mile away. And the Guinness World Record holder at number 1 costs more per hour to run than most people earn in a day. Before we start, here is some context. These are not the loaders you see on construction sites. These are mining titans designed to fill 400-ton haul trucks in minutes. They operate in open pit mines so deep you could stack 3 Statues of Liberty on top of each other and still not see over the rim. The average wheel loader operator in the United States earns about $40,000 per year. The machine underneath them is worth up to $5 million. That is a ratio of 1 to 125, human salary to machine value. Keep that number in your head as we go through this list. We are ranking by what I call the monster factor: 50% size and payload, 25% raw power and drivetrain technology, and 25% for the engineering story behind it. Because the craziest thing about these machines is not always the specs. Sometimes it is the problem they had to solve to build them in the first place. Number 10. The Hitachi Zedu 556, the Japanese precision machine. 48 tons and a 10 cubic meter bucket might sound modest compared to what is coming. But this loader does something none of the bigger machines can match. The dump cycle time is 3.2 seconds. That is faster than most people can count to 3. The raise time sits at 14.8 seconds. Combined, you are looking at an 18-second full cycle from scoop to dump and back down again. In an 8-hour shift, that speed advantage adds up to roughly 20 extra loads compared to slower competitors. 20 extra loads per day, 300 operating days per year, multiplied by whatever tonnage sits in that bucket. You are talking hundreds of thousands of dollars in additional annual revenue from cycle speed alone. The engine is a Cummins QSK-19, 6-cylinder, turbocharged, pushing 531 horsepower. And here is the detail that separates Hitachi from the pack. This loader meets United States Environmental Protection Agency Tier 4 final emissions standards. Most mining loaders completely ignore environmental compliance because they operate in places where regulators do not visit. Hitachi built the ZW556 to work legally anywhere on the planet. Japanese precision versus American brute force. Different philosophy, same result. Number 9. Volvo L350H, the fuel efficiency king from Sweden. 51.7 tons, 7.7 cubic meters, 400 horsepower from a Volvo D16 engine. Solid numbers, but the real story starts in 1954. That was the year Volvo invented the wheel loader. The first one was called the H10, 35 horsepower, 3-cylinder diesel, and it was literally inspired by a tractor built backwards. Swedish engineers looked at a farm tractor and thought, what if we reverse the operator position and bolt a bucket to the front? That backwards tractor idea created an entire global industry worth billions today. The H10 now sits in a museum. The L350H is its great-great-grandchild, 72 years of evolution later. What makes this loader relevant in 2026 is fuel efficiency. Volvo claims 20% better fuel economy than the previous generation. In mining operations running loaders 24 hours a day, 7 days a week, that 20% on a machine burning 30 gallons per hour saves over $50,000 per year in diesel. Scale that across a fleet of 20 loaders, and you have just saved $1 million annually on fuel alone, without moving a single extra ton of rock. And here is the fact that will make you question Swedish engineering judgment. A modified Volvo L60G wheel loader once hit 120 kilometers per hour on a 1.8 kilometer runway in Sweden. That is 75 miles per hour. A 50-ton machine with a bucket on the front doing highway speed. The Swedes are quietly insane. Number 8. Komatsu P&H L1350. The mid-range Powerhouse, 186 tons, 23 cubic meter bucket, 1,600 horsepower. Those numbers are solid, but the real story is precision loading. This machine was designed specifically to fill 181 to 236-ton haul trucks in exactly 4 passes. Mining operations obsess over passes per load. Every additional pass burns more fuel, adds more cycle time, and wears down both machines faster. The L1350 hits that 4-pass sweet spot for mid-tier mining trucks perfectly. The dump clearance reaches 23.2 feet, 7 meters above the ground. That height allows operators to clear the massive sidewalls of haul truck beds without scraping. The reach at full lift extends 9.2 feet, which lets the operator position the bucket deeper into the truck bed and distribute the payload evenly. This matters because uneven loading destroys haul truck suspension components 30 to 40% faster. Protecting a $4 million truck's lifespan is part of the loader's job description. Komatsu acquired P&H through Joy Global in 2017. P&H had been building mining shovels since 1914. That is over a century of institutional knowledge about moving rock at industrial scale. When Komatsu bought them, they did not just get a brand name. They got 3 generations of mining engineers who understood loading geometry in ways computer simulations still cannot fully replicate. Number 7. BelAZ 78250. The remote-controlled monster from Belarus. 107 tons, 15 cubic meter bucket, 1,500 horsepower from a Cummins engine. But none of those specs compare to the headline feature. This machine was operated from 1,500 meters away. That is nearly a mile, using remote control technology. Picture this. You are sitting in an air-conditioned control room on the surface, looking at screens and holding a joystick. The loader you are driving is 1,500 meters away at the bottom of a potash mine, scooping material and loading trucks. You cannot see it with your eyes. The remote system uses a combination of onboard cameras, LiDAR sensors, and real-time telemetry with latency under 50 milliseconds. When you move the joystick, the bucket responds before you can blink. BelAZ tested this in Belarusian potash mines at depths exceeding 1,200 meters. At that depth, ventilation alone costs millions per year. Remove the human operator from the pit, and you can cut airflow requirements by 30%. Here is the geopolitical angle. Belarus is one of the last countries building heavy industry the old Soviet way. While Caterpillar and Komatsu moved supply chains to China and Mexico, BelAZ kept everything in-house in Minsk. They produce machines so large they cannot leave the factory in one piece. The 78250 gets shipped in sections and reassembled wherever it is going. Post-Soviet engineering at its most stubborn and impressive. Number 6. Komatsu WA-1206, the world's largest mechanical drive wheel loader. 220 tons with a 35 cubic meter bucket. And here is what makes this machine unique in this countdown. It is the biggest loader on Earth that still uses a traditional mechanical drivetrain. No diesel-electric hybrid, no electric wheel motors. Pure mechanical power transfer from engine through transmission to axle. Why go mechanical when everyone else is going electric? One word: simplicity. Mechanical drivetrains are easier to repair in remote locations. When you are operating in the Australian outback or Chile's Atacama Desert, 2,000 kilometers from the nearest specialized electrical technician, you want a machine that mechanics can fix with wrenches and common spare parts. The breakout force on this loader measures 286,600 pounds of force. That is 1,275 kilonewtons of hydraulic ripping power for when blasted rock has not fully fragmented. Komatsu also equipped this with their Comtrax Plus YOT monitoring system, tracking fuel consumption, idle time, and payload per cycle in real time. The system reduced fuel waste by 12% across Komatsu's trial fleets. On a machine burning 40 gallons per hour, that saves about 5 gallons every hour, which works out to over $100,000 per year, per machine, in fuel alone. If you are still watching, we have not even reached the truly absurd machines yet. Number 5 brings China's electric revolution. Number 2 is Caterpillar's newest loader that is rewriting how copper mines calculate productivity. And number 1 has locomotive engines, house-priced tires, and a development story that involved creating rubber technology that did not exist. Hit the like button if you want more construction equipment deep dives, and drop a comment. Should our next video cover the biggest mining dump trucks or the last cable-operated shovels before hydraulics took over? Now let us get to the top 5. Number 5. XCMG XC9350, China's electric revolution. 170,000 kilograms, an 18 cubic meter bucket, 970 kilowatts, which is about 1,300 horsepower. But the horsepower number is misleading because this loader does not work like traditional machines. The diesel engine does not connect to the wheels directly. It spins a generator. That generator feeds electric motors mounted in the drivetrain. When the loader brakes or lowers a loaded bucket, the system captures kinetic energy and stores it. Regenerative braking, the same principle Tesla uses, scaled up to a 170-ton mining machine. XCMG claims 18% fuel reduction compared to mechanical loaders. In a 12-hour shift, that translates to saving roughly 84 gallons of diesel per day. At $3.50 per gallon, that is almost $300 saved daily per machine. Over a full operating year, you are looking at $100,000 in fuel savings. But the real disruption is price. XCMG sells this loader for about 40% less than a comparable Caterpillar or Komatsu. Not because the quality is lower, because 70% of its components are manufactured within a 500-kilometer radius of the XCMG factory in Suzhou, China. Western manufacturers import hydraulic pumps from Germany, engines from America, tires from Japan. XCMG builds almost everything locally. China now produces more mining loaders than the United States, Europe, and Japan combined. They passed everyone in 2021. The XC9350 is not just a machine. It is a statement about where heavy equipment manufacturing is heading. And it is heading east faster than Caterpillar wants to admit. Number 4. Caterpillar 994. K, the 25-year champion. 242 tons, 43 cubic meter bucket capacity, 1,870 horsepower from a Cat 3.5.1.6e engine. This machine has dominated its size class for over a quarter century, not because it is the biggest or the most powerful, Because it is the most reliable loader, ton for ton, ever manufactured. The engine displacement is 78.1 liters. To put that in perspective, a Ford F-150 pickup has a 5-liter engine. The 994K has the equivalent displacement of 15.5 Ford F-150s bolted together. 16 cylinders of direct injection turbocharged diesel that consumes about 3 gallons of fuel just during startup. The hydraulic reservoir holds 382 gallons. The cooling system holds another 130. That is over 500 gallons of specialized fluids that need monitoring, filtering, and scheduled replacement. A single hydraulic fluid change costs roughly $15,000 in parts and labor. But mining operators perform that service religiously because a catastrophic hydraulic failure on a 994K costs $200,000 in emergency repairs and about a week of downtime. In a large copper mine, 1 week without a primary loader means over $3 million in lost production. That $15,000 fluid change is the cheapest insurance policy in mining. Caterpillar also designed the 994K with backward-compatible buckets. The attachments from the older 994F fit the K model perfectly. That saved mining companies millions when upgrading fleets. It is a small engineering decision, but it reveals why Caterpillar owns this market segment. They understand that buying the machine is 20% of the total cost. Operating it for 20 years is the other 80%. Number 3. Komatsu P&HL 1850, the hybrid power beast, 242 tons, 30 cubic meter bucket. 2,000 horsepower. But those numbers hide the real innovation. This is a hybrid loader running an SR drive system, synchronous reluctance technology. The same principle inside a Toyota Prius, scaled up to 242 tons. The diesel engine powers a generator. That generator feeds electric motors at each wheel. When the loader descends a ramp or lowers a loaded bucket, those electric motors reverse into generators, capturing kinetic energy and feeding it back into the system. Komatsu claims this recovers up to 15% of energy that traditional hydraulic systems waste as heat. The dump clearance reaches 24.3 feet, 7.4 meters. The loader fills 240 to 360-ton haul trucks, and those trucks sit high. Every time you lift 40 tons of rock 7 meters into the air and then lower the empty bucket, you are throwing away enormous amounts of potential energy. The hybrid system grabs that energy and reuses it on the next lift cycle. The breakout force exceeds 300,000 pounds force. That is enough hydraulic pressure to theoretically lift a fully loaded Boeing 737 off the tarmac. The L-1850 does not just load loose gravel. It rips into blasted rock formations that have not fully fragmented. Komatsu installed the Lynx 2 monitoring system that tracks load weight per bucket using hydraulic pressure sensors in real time. Overloading a haul truck by even 10% cuts tire life by 30%. A set of 6 tires for a 360-ton truck costs about $200,000. The Lynx system pays for itself in avoided tire replacements within 6 months of installation. If you have made it this far, the final 2 machines are on a completely different level. Number 2 is Caterpillar's newest mining loader, and it delivers 33% more productivity from a single engineering breakthrough. Number 1 holds the Guinness World Record, uses locomotive propulsion technology, and required its builders to invent new tires because none existed that could carry it. Subscribe if you are into construction and mining equipment breakdowns. We have videos coming on the Caterpillar death memo that calculated 600 worker deaths per year and did nothing about it. The leaked documents are something else. Hit subscribe so you catch that one. Now Number 2, Caterpillar 995. The production beast. 245 tons a day. 43.6 cubic meters of bucket capacity, 1,840 Newton horsepower from the CAT 3516E engine family. Full production started in 2023, and this machine is already reshaping how mines calculate their numbers. The engineering breakthrough is torque. The 995 delivers 39% more torque than the 994K it replaces. Same engine family, completely redesigned drivetrain. Peak torque hits 8,549 pound-feet at 1,200. Revolutions per minute, that 78.1-liter engine now pushes 15 times the displacement of a Ford F-150, but with a drivetrain built to translate that power into faster cycle times and harder material penetration. The real revolution is one-pass loading. Caterpillar designed this machine specifically to fill their 785, 789, and 793 haul trucks in a single scoop. Most loaders need 3 to 4 passes per truck. One pass instead of 4 means 33% more material moved per shift with the same operator, same truck, and the same number of working hours. No new hires, no additional equipment, just a bigger, smarter bucket on a more powerful machine. CAT also made the buckets backward compatible with the 994K. Mining companies running existing fleets can upgrade to the 995 without replacing their entire bucket inventory. That compatibility saves $5 to $10 million per mine site in retooling costs. The price tag sits at roughly $6.5 million, about 20% more expensive than a comparable Komatsu. Caterpillar's argument is straightforward. If the machine moves 33% more material, it pays for itself in 18 months compared to the cheaper competitor. The math works if, and this is a significant if, the reliability holds. CAT is betting decades of reputation on that claim. The 995 is operating right now in Chilean copper mines, Australian iron ore operations, and Nevada gold pits. If the uptime numbers survive the first 5 years of hard data, this will be the dominant mining loader of the 2030s. Number 1. Komatsu WE2350, originally the Letourneau L2350. The Guinness record holder for the largest wheel loader ever built. 276 tons, a 53 cubic meter bucket, 72.5-ton payload capacity, 2,300 horsepower from an MTU 16-cylinder diesel, and tires that cost $63,000 each. Let us start with the problem that almost killed the entire project. When Letourneau's engineering team in Longview, Texas began designing this machine in the early 1990s, they spent 2 full years of development. They calculated the structural loads, designed the hydraulic systems, selected the engine, and engineered the frame. Then they got to tires, and everything stopped. No tire manufacturer on the planet made a tire large enough to support this machine at operating weight. The required tire simply did not exist. Letourneau entered a joint development partnership with Firestone to create an entirely new tire from the ground up. 13 feet tall and 5 feet wide, engineered to withstand extreme cyclic loading and heat buildup that would destroy any existing mining tire. That development process took 18 months on its own. The tires became the single longest lead time component in the entire build, not the custom MTU 16-cylinder diesel, not the hydraulic pumps, the rubber, and each one costs $63,000. 4 tires total means $252,000 just to put this machine on the ground. Front tires last about 6,000 hours. Rear tires get roughly 14,000 hours. Each individual tire weighs 15,000 pounds. Now here is the truly extraordinary engineering decision. This loader does not use a mechanical drivetrain. It runs diesel-electric propulsion, identical in concept to a Union Pacific freight locomotive. The MTU engine does not connect to the wheels. It drives a G200 SR generator. That generator powers 4 independent B60 SR electric motors, one mounted at each wheel. This is railroad technology adapted for a mining loader. Why diesel-electric at this scale? Because mechanical transmissions cannot handle 2,300 horsepower at these torque loads. You would need a gearbox the size of a compact car just to transfer power to the axles. Electric motors deliver full torque instantly from 0 RPM, and each wheel can be controlled independently for traction management on uneven pit floors. The fuel consumption is staggering, 50 gallons per hour. The fuel tank holds 1,050 gallons, giving roughly 21 hours of continuous operation. At $3.50 per gallon, that is $175 in diesel every single hour. A 12-hour shift costs $2,100 in fuel alone. Add the operator's wage, maintenance costs, tire depreciation, and you are looking at roughly $4,000 per shift to keep this machine running. That is about what a cardiac surgeon earns in the same 12 hours. But here is why the economics still work. The WE-2350 loads a 400-ton haul truck in 5 passes. A smaller loader takes 12 to 15 passes for the same truck. Those extra passes add minutes per truckload, which becomes hours per day, which becomes weeks per year of lost productivity. In a copper mine producing 1 million tons annually, those lost weeks translate to tens of millions of dollars in missed production. The $4,000 shift cost is a rounding error compared to the revenue this machine generates. The first prototype cost $5.5 million. It was commissioned in 2002 at the North Rochelle mine in Wyoming, operated by Triton Coal. The machine was revealed at Mine Expo in Las Vegas in the year 2000. It ships from the factory in 11 separate truckloads and requires approximately 6 weeks of on-site assembly with a specialized crew. You cannot transport this thing assembled. It is physically too large for any road or rail system on Earth. Komatsu now owns the design after acquiring P&H Mining, which had previously purchased Letourneau's mining division. Fewer than 50 of these machines have ever been built. There are exactly 3 operating in North America right now. Chile has 2. Australia has 1. This is not a mass-market product. It is a custom engineering solution for the deepest, largest-scale open-pit mines on the planet. This is the limit. Not because engineers cannot build bigger. They probably could. But because at some point, the physics of rubber, steel, and diesel combustion stops making economic sense. The WE-2350 sits right at that edge. One step larger, and you would need to rethink the entire concept. Maybe tracked propulsion instead of wheels. Maybe fully autonomous swarms of smaller machines coordinated by artificial intelligence. Maybe battery electric systems that charge between shifts. For now, this is the king, and the crown costs $63,000 per corner. From the Japanese precision of the Hitachi ZW556 to the Chinese electric revolution of XCMG to the tire-inventing, locomotive-powered, house-priced Guinness record holder at number 1. Those are the 10 biggest wheel loaders moving rock across the planet right now in 2026. Here is the question that keeps mining engineers awake at night. We have reached the physical limits of rubber tires and diesel-electric systems. The next generation might look completely different. Fully autonomous loaders with no operator cab at all. Battery electric machines that produce 0 emissions underground. Or maybe something nobody has imagined yet. Drop a comment and tell us what equipment deep dive you want next. Biggest dump trucks? The last cable excavators before hydraulics killed them off? Or the full breakdown of the Caterpillar internal memo that calculated 600 worker deaths per year and decided the math was acceptable. That video is coming, and the leaked documents are wild. If you made it to the end, hit subscribe. We cover the biggest, the oldest, and the most dangerous construction equipment on Earth every single week. Check the video on screen for more. See you in the next one.